So now we are starting with bases. So let's start. So bases are what? Bases are actually either a metallic oxide or a metallic hydroxide. Oxide is what? Which is having oxygen. Hydroxide is what? Which is having, it is having oxygen, and hydroxide is what? It is having OH, that is of hydroxide. Okay, so let's just discuss, let's first understand what is the base first of all. Okay, so base is either a metallic oxide or a metallic hydroxide, as I've already told you, or it can also be ammonium hydroxide. Okay, ammonium hydroxide, ammonium hydroxide. What is ammonium hydroxide? I've already told you in the previous lecture that ammonium is not NH3. It's actually NH4, है ना? So NH4OH is ammonium hydroxide. So now it reacts with hydronium ions of an acid to give salt and water only. Okay, so bases are what? I'll just make a flow chart. So bases are either oxide, hydroxide, or ammonium hydroxide. These are oxide, hydroxide, okay, or ammonium hydroxide, and these all, when they react, okay, with an acid, when they are reacted with an acid, they actually react with the hydronium ion. We all know that acid is having an positively charged hydrogen ion, isn't it? So it reacts with the hydronium ion and gives us what? And gives us salt and water. Salt plus water. And this salt and water formation is known as what? Neutralization reaction. Okay, neutralization reaction. Let's discuss some examples to prove this. So the first example is, let's take an oxide first, an oxide first. So what can an oxide be? CuO. Cu is a metal, copper, and oxide. Its oxide is copper oxide. Okay, or cupric oxide plus HCl, that is an acid. So what we have studied just now, acid reacts with bases to give us what? Salt and water. Yes, so let's write salt and water. Which salt we'll get? We'll get CuCl2 plus H2. Okay, let's discuss another example. Another example. Let's take it from hydroxide. Let's take the hydroxide of copper only. CuOH whole twice plus any acid. Let's take H2SO4. What we'll get? We'll get again a salt and water. So let's write water. Okay, because it's a complicated reaction. So H2O for sure we'll get. So we have already utilized this H of an acid. Okay, and we have already utilized this OH also, which has given us H2O. It will be actually 4H2 when we'll balance it. Okay, so no, not 4, it will be 2H2. Okay, and what else is left? We are now left with CuNSO4. So this is a salt, CuSO4, that is copper sulfate. Okay, so this was an example of metallic hydroxide. Okay, same goes for the alkali as well. No, for ammonium hydroxide as well. Now we come to what is alkali. It's a very important favorite question from the boards. Alkalis, what are alkalis? An alkali is a compound, an acid which is dissolved, which is soluble in water. Okay, base soluble in water. Okay, very important. It's soluble in water. Okay, it is soluble in water. Is it clear, everyone? Is it clear? So bases which are soluble in water are actually alkalis. So let's discuss what is the main types of alkalis. So see, First of all, note this, that all alkalis are bases, but all bases are not alkalis. Very common sense type of a statement, because all alkalis are actually a type of base only, na, but they're soluble in water. But it's not necessarily that every base is soluble in water. So all bases are not alkalis. Okay, I hope this is clear. Now, an alkali is a compound which I've already told you, which when dissolved in water gives us what? OH as the only negatively charged ion. Okay, and this gives us what? This gives us OH minus. Okay, okay, so and this plus water, when it is an aqueous state, plus water will give us what? Will give us OH minus for sure. Okay, I hope that this is clear. So let's discuss an example for this. Yeah. So let's discuss an example for this. Let's take an example of sodium hydroxide, NaOH. Okay. So when it is dissolved in water in its aqueous state, it will give us what? OH minus for sure. Now we are left with what? We have taken OH. Now we are left with Na only. Okay. Na. It's in water. So no, we'll not show water. That's why when we write these kind of an equation, we don't show that it is reacting with water. We actually write it as NaOH in aqueous, like this. And it will give us what? Na plus and OH minus. I hope that this is crystal clear to everybody. Right. So an alkali is a base soluble in water. All alkalis furnishes us with this OH. Okay, very important. Very important. So now let's come to the classification of bases. Like we have classified acids in our previous lecture, let's see the classification of bases. Very important, remove from the syllabus, so we'll not discuss that. Classification of bases, let's see. First of all, we'll talk about some bases. So first of all, the bases will be, let's take the bases as on the basis of their strength. So who will tell me that when we have classified acids, we have classified them on the basis of the strength? How many types of acids were there on the basis of their strength? Tell me fast, quickly.
Strong and weak.
Strong acid, weak acid.
Very good. So here we'll get what? Tell me. We'll get the same thing. Strong
It's strong
and
base or weak base.
very good, Rajat. Strong bases and weak bases. So strong bases are what? Which completely ionize in water, and weak bases are what? Which partially ionize. Okay, so they are what? Same thing with, which was with the acids. Okay, so they ionize completely in aqueous, and they do what? They do not ionize this partially in aqueous state. Okay, I hope that this is clear. Now let's talk about another basis. So let's now take the basis of acidity. Like in acid, we have basicity. Okay, we had basicity. Here we have acidity. See, these are two opposite things. In acid, we had basicity, and in bases, we are having acidity. Now tell me how many types of acids were there on the basis of their basicity? Who will tell me? Tell me first.
Monobasic, dibasic, and tribasic.
Yeah, the same thing goes here as well. Here we'll not write basic because we are talking about acidity. So we'll say monoacid. Okay, monoacid, diacid, and triacid. Okay, triacid. Let's see what are these. In this we have how many oxygen? We are having only one hydroxyl per molecule of base. So we are having one hydroxyl. What is hydroxyl? I hope that everybody knows what is hydroxyl. Yes, hydroxyl is nothing but this OH. We know that every base is having this OH, NaOH, COOH. Yes, isn't it? So we are having one hydroxyl per molecule. Okay. In diacid, we are having two hydroxyl per molecule. And in tri-base acidic, we are having what? I'm sorry if I said dibasic previously. Now triacid, we are having 3 hydroxyl per molecule. Is it clear? I hope that it's clear. Now let's come to the property of acids. So property of acids is not there in the syllabus, but you should be knowing them. Okay, so we'll just describe them orally only. We'll not dive into the chemical properties. Let's just see the physical properties. We all know that bases, that acids were what? They were sour in taste, but bases are what? They are bitter in taste. Okay, they are bitter in taste. They are soapy. Okay, like soap, they are soapy. Okay, and they are very less corrosive. That means they are mild corrosive. What we call them? We call them mild corrosive. Okay, next, very important, that if we had a red phenol, red litmus, okay, we had a red litmus, if we add a base to it, okay, it will be converted into what? It will be converted into blue litmus paper. Is it clear? I hope that it's clear, because in acid the reverse happens. When we add acid to this, when we add acid to this will become red. Okay, I hope that it's clear. That's all for the physical properties. Now let's move on to the strength of acidic and basic solutions. So now we are discussing the strength of acid and basic solutions. So let's see. So strength of acid and basic depends on the number of hydrogen ions or hydroxyl ions produced by them respectively. Like acids will produce what? They will produce hydrogen, positively charged hydrogen ions, and bases will produce, we all know that acid produces H plus and bases produces OH minus. Okay, so when the more the number of this hydrogen ion, more acidic is the acid. Okay, more corrosive. Okay, more the number of hydroxide, more the strength of the bases. Okay, so large the number of hydrogen ions produced by an acid, stronger is the acid. Similarly, larger the number of hydroxyl ions produced by the base, stronger is the base. So that's all for the strength of acids and base. This was all for today's session. Please like, share, and subscribe to my channel if you haven't, and please let me know about your views in the comment section below. Thank you for watching. Please share the video with your ICSE classmates.